Hello everyone, you are welcome to the GMAT 41's YouTube channel. I am delighted to meet you once again. I hope you are doing very fine. So today, in our class, we are going to be looking at organic chemistry, Iupac Nomenclature specifically. Interacting with students, alright, both O-level students in the SS3, SS2, A-level students, especially those in 100 level, 200 level, talk about chemistry, and of course I've come to observe by what most of the students say that organic chemistry is an aspect of chemistry that they usually find very tough, okay? Nonetheless, I understand, sometimes it could be maybe the way we approach the subject or course. Other times it could be maybe the way this part of chemistry has been presented to us, perhaps when we first had the opportunity to learn it. All the same, Engineer Maka has always maintained that technically nothing is too difficult. If you want to learn something, it's only when you give up in learning it. And so just like I've done exposing certain tricks in calculus, I have also determined to put up to my channel and of course to my friends out there, works on organic chemistry. And so by this I am urging you to follow us, subscribe to the GMAT 41's YouTube channel, turn on the notification bell so that once I upload any content, alright, you will be personally notified in order to be carried along so as to learn this part of chemistry. It's interesting to tell you that in advanced level in the university or higher institution, organic chemistry is extracted as a part of chemistry and studied as a course. Now you can see, holding on my hand, this paper, okay, this is just review of organic chemistry that I've made for quite a long time now. Okay, here I played with organic chemistry and of course made a simplified summary of it. And so I've decided that this works on paper should come online so that my friends will also get access to them. I will be focusing on Iupac Nomenclature in this video lesson, maybe a few others to come. But then for detailed understanding of organic chemistry, because it's important for students to learn it step by step. Is that okay? In SS3, in advanced level, 100 level, you are expected to pick alkanes, alkynes, alkanol, alkanal, alkanone, alkanoic acid, the derivatives of alkanoic acid like the acid amide, acid chloride, acid anhydride, the esters, that is alkyl alkaloids, and then of course the nitrites. You are expected to learn them, okay, each of them. So for detailed understanding of the full course in organic chemistry, I am urging you to contact the GMAT 41, and just with a paid subscription at an affordable rate, you can join our full range of learning classes on Telegram, where we'll deal with each of these homologues in details. But here, I will be dealing with the nomenclature of these homologues, starting with alkane. Please, like, comment on these video lessons, share the video lessons, invite your colleagues, your friends to also subscribe to the GMAT 41's YouTube channel in order for us to carry you along and coach you on how to handle organic chemistry, 1+1. Remember, for GMAT 41 will never disappoint. So we are coming against this organic chemistry, okay? Starting with this video lesson to deal with the nomenclature. So right away, we'll be kicking off with the alkanes. So here we go with our very first homologue, alkanes. We're going to look at the Iupac nomenclature of alkanes. And on the board here, you have our very first structure. Okay? So how did I know that it is an alkane? The functional group of alkanes is single bond. And how do we identify rate? Between the carbon atoms, you will be seeing single bond connecting the carbon atoms. Hey, I've decided not to give you a list of rules. Don't worry. As you're moving on in dealing with the structures, I'll be releasing the rules gradually as applied to a particular structure we'll be dealing with. I think with that, if you put everything together, of course, it will make more sense than just giving you a list of rules to go and cram. But then before we move on into this structure, let me say this. This one is a little secret. Very important that you do what I'm going to tell you. You have no choice. I have no choice, please. And so that's why I'm going to say this. You must have to cram. You must have to memorize the first 10 members of alkane family. Once you memorize the first 10 members of alkane family, I tell you the truth. In fact, you've known everything about Iupac Nomenclature of other homologs. So for that reason, I'm going to run down through the first 10 members of the alkane family. And as I do that, make sure that in the next 24 hours, you've memorized these first 10 members. Don't scatter them. The way I'm going to give you the list, that's how you are meant to memorize them. So are you ready? Number one member of the alkane family is methane, 2, ethane, 3, propane, 4, butane, 5, pentane, 6, hexane, 7, heptane, 8, octane, 9, nonane, 10, decane. This list, you are expected to cram them accordingly. It's just like the way we have the first 20 elements. You are not allowed to scatter them, please. Because this serial arrangement from methane to decane indicates the number of carbon atoms that the structure or the compound you're dealing with has. For example, when we say pentane, it means there are 5 carbon atoms. Number 5, you can say that in the serial number. When you say propane, number 3. What of nonane? Number 9. What of methane? Number 1. Ethane? Number 2. Come along, please. Let's deal with our first structure here. Now, the first thing you do when you want to give the Iupac nomenclature of any structure is to determine the longest carbon chain, whether it is the straight chain or the branched chain. Which one is longer? You must determine that first. That is rule number 1, and it applies to all the homologs we are going to treat. I hope you've put that down in your memory, right? Put it down, okay? Determine the longest carbon chain. So let us do that here. Which one is the longest carbon chain here? I have on the straight line here, carbons. Then if you also go this way, you have a branch chain linking carbon as well too. If I decide to count this straight chain, 1, 2, 3, 4, 5. There are 5 carbon atoms along the straight chain. If I decide to go this way, 1, 2, 3, 4, 5. Because in counting, you can count along the straight chain or along the branch chain. If you also want to waste your time, you can decide to count this one as well. Imagine somebody counting this one in exam 1, 2, 3. Remember, our eyes can also read and determine maybe how lengthy something is. If I am in the exam hall, I won't check for this because there's 3 carbons there. I can only check for this straight chain or maybe this one. And either of them give us 5 carbon atoms. I always advise, if the straight chain gives you the same number as the branch chain, take the straight chain, analyze the branch as an attachment. That is what I like doing. But even if you take the branch chain as 5 carbon atoms there, being longer, alright, it will still give you the same nomenclature. So don't be scared, don't be worried. But I prefer taking the straight chain if the straight chain and the branch chain are the same in number. What have you learned so far? 2 things as rules. Number 1, you have to find out that this is an alkane. And I've told you the reason. Put it down. Between the carbon atoms, you have single bonds, single lines. You can see that. Good. And then number 2, you should determine the longest carbon chain. And we found out that the straight chain is 5. Then if you come this way also in the branch chain, it is 5. I decided to take the straight one. So that the parent chain will now be 1, 2, 3, 4, 5. Any carbon atom that I do not count among the longest chain becomes an attachment. Is that okay? So having said that, let's go. This becomes an attachment. I know that the longest carbon chain is 5. Good. The third thing that you want to think about is, now I know the longest carbon chain, that is 5. Question, where will I start my counting from? Will it be from the left or from the right? Now this is an alkane. Let me say something. Generally, the side you count from, you can put this down. Generally, the side you count from when you are dealing with any homologue depends on where the functional group of the homologue is closest to. But we don't usually use that for alkanes, because alkanes, the functional group is single bond, and between the carbon atoms, everywhere you see single bonds. Are you following, right? So what will guide us when dealing with alkanes? What will guide us to know where we count from is the side that we cite, the side that we see our first attachment faster. What do I mean by that? Now take a look. If I'm counting from here, 1, 2, you notice that on the second carbon atom, I have this attachment. So my attachment is on number 2, going 1, 2, 3, 4, and 5. But if you count from the right, 1, 2, 3, you know this is also an attachment, this chlorine, because it is not hydrogen, it is an attachment. Of course, it's not part of the carbon parent, that is the parent carbon. So it is also an attachment. So going by this way, 1, 2, 3, 4, 5. You notice that your first attachment was cited on carbon number 3. But if you are going from left to right, it's on carbon number what? 2. Therefore, it means that the right direction to count from will be from the left to the right. Another thing that will help you to know the direction to count from is the direction that will give the lowest sum, the lowest number to the attachments. Let's do that quickly and see. If you are counting from left to right, on the second and on the third, you have attachments. If you do 2 plus 3, you get 5. That is counting this way. Now, if you are counting this way, you notice that your attachment will be located on number 3 and number what? 4. 3 and 4. If you do 3 plus 4, you get what? 7. The smallest sum, the smallest addition is this one, which is counting from left to what? Right. So that simply tells us that for this structure, I am going to count from where? Left to right. Our problem is solved. It is now time to name this. Remember, the parent chain has 5 carbon atoms. Therefore, this would be pentane. Because in that our list, I hope you still remember, 5 carbon atoms correspond to what? Pentane in the alkane family. Alright, so we go. Are you ready? To give the nomenclature now, we are going to start with the attachments. This CH3 is called methyl. It's called what? Methyl. It is an alkyl. Alkyl is an alkane that has lost 1 hydrogen. Well, gradually all this will fix up. CH3, 1 carbon, 3 hydrogen is methyl. Are you following, right? So this is methyl. Take note, it starts with N. And then if you come here, this is chlorine. Chlorine, this attachment, it starts with C. But let me indicate it, chloro. And this is methyl, eel, and alkyl. Now, to give the nomenclature of this structure, the next rule set, we call this one the alphabetization rule. Starts with the attachment which has the first letter. If you come to your ABCD, or maybe if you come to your dictionary arrangement, are you following, right? Methyl starts with N, chloro starts with C. Which one will you meet first if you are looking at your 26 alphabets? Or if I tell you go to dictionary and check which one will you see first in dictionary order, chloro will come first because it starts with C. It simply means you're going to start with chloro. Now, while writing this, we need to indicate a carbon atom that is bearing the word chloro. And the parent carbon atom bearing it is carbon atom number 3. So this becomes 3-chloro. Then methyl is on the second carbon atom. Remember, the correct order of counting is left to right. So I'm using the blue numbering. Are you following, right? Not the blank one from right to left. Good. So coming over to this, we have on the third carbon atom, remember you're starting with chloro. I've explained the reason. Then on the second carbon atom, you have methyl attachment. So this is actually 3-chloro, 2-methyl. There is no other attachment. Hydrogens are not attachments when dealing with Iupac nomenclature. The longest chain is 5, which corresponds to pentane when dealing with alkane. So this is 3-chloro, 2-methyl, pentane. Good. Now we are done with this structure, and honestly, I advise you to replay this video, listen to all the explanation, make your points down, because as we move on to structure number 2, we won't waste time doing all the full analysis again. Everything necessary have been explained here. Let me say 95% of what you should know in organic chemistry in terms of the Iupac nomenclature has been explained with this structure. So moving on to number 2. And now we have our second structure. This is a structure. The first thing you have to do is to identify the homologue that this structure belongs to. Of course, we are dealing with alkanes. So I might just say, there's an alkane, because that's what we are learning. But I don't want you to have that reason. You should know why a particular structure belongs to this or that homologue. This is an alkane because if you look through, between any two carbons, are you following right? The bond you have there is single bond, just one line between them. And that is what we refer to as the functional group of alkanes, single bond. You can see that along this straight chain between any two carbons, you have one line between them, single bond. Along this branch, the same thing, single bond. This branch, single bond. What about this? Single bond. That is why this is an alkane. Alright, that's good. Now we've been able to identify that this is an alkane. The next thing we have to do is to find out the longest carbon chain, which can either be a straight chain or a branched chain. It is now your duty to look at that and find out which direction is the longest. But of course, you want to be careful. Don't go counting the one which you even know, looking at it, that this one is not as long as the other one. For example, imagine this branch. You know we have only 4 carbons there. And they want to go count it in example. Anyway, let's move on, please. Let's move on. But there is a structure we're going to consider as we move on, where something may happen and maybe the shorter structure might be the longest carbon chain. Don't worry until we get there. We don't have such issues with alkanes. Are you following right? We don't. So don't bother yourself about that. Just know that generally, the longest carbon chain is what you check for. Is that okay? And I think it must contain all reactive functional groups. But we're just starting, so let's move on. Now, if I check the straight chain here, I think we've got 5 carbon atoms. 1, 2, 3, 4, 5. But if you go this way, 1, 2, 3, 4, 5, 6, 7. 7 is longer than 5, so the straight chain cannot be the longer chain. Are you getting me? We've seen 7 already. What about if you go this way? 1, 2, 3, 4, 5, 6. 6 is shorter than 7. In fact, I wouldn't want us to waste our time much. The longest chain here is that one with 7 carbons. You can find out, count all the other chains and see. Now, having noticed that the longest chain is this, 7 carbon, the next thing now is to find out where do we count from. Is it from this direction or from this direction? Like I said, when we are analyzing structure number 1, 2 things can guide you. Number 1, where the functional group is closest to, which does not apply to alkanes, because alkanes, between all the carbon atoms, we have single bonds. If it's something like alkene or alkyne or other homologues we are treating, we check for where the functional group is closest to. Don't worry, we'll come to that. Is that okay? In the case of alkanes, what will guide us is, as a reminder, because I said in instruction number 1, where you cite your attachment first. If you count from here, 1, 2, 3, on the 3rd carbon atom, you see your attachment. Remember, I did not count this among the longest carbon chain. So it is an attachment. Let me circle it. Let me just take note of it. Are you following? So on the 3rd carbon atom, counting this way, you have your attachment cited. What about if I go this way? Now you have 1, 2, 3, 4. That is on the 4th carbon atom. Carbon atom number 4, you cite your attachment. Carbon atom number 4, you see your attachment counting from down up this direction. Is that okay? So clearly, this one is smaller than this. So you assign your attachment first, counting from this direction. So for this structure, surely the counting should be in this way. Are you following right? But again, you can use the idea of the direction that gives you the lowest sum to the attachment, which in that case we have to number 1, 2, and 3, then we have 4, 5, 6, and 7. You notice that on carbon number 3 and carbon number 4, you have attachment if you are counting like this. 3 plus 4 will give you 7. Now let us check in this direction. I guess that's going to be on 4th carbon atom, you have an attachment. This is attachment, this thing, because we didn't count it among the parents chain. Then on the 5th carbon atom, we also have another attachment. That is going this way. And so 4 plus 5 will give you 9. In fact, let me put the numbering. 1, 2, 3, 4, 5, 6, and 7. So on the 4th and on the 5th carbon atom, you've got your attachment there. If you do 4 plus 5, this will give you 9. Now I'm going to ask you, 7, which going this way, you know, and then 9 going this way. Which one is smaller? That's correct. The lowest sum is 7. Are you following right? So this direction becomes the right direction to count from. This way. That's good. Now that we've decided and selected the right direction to count from, let us look at the attachment. This is methyl. Are you following right? CH3. You see? Methyl. For an alkane, it's supposed to be CH4. Generally, alkenes, which we usually see as attachment, are you following right, in structures, they are alkanes minus 1 hydrogen. One carbon atom as an alkane should have 4 hydrogen atoms around it. But if you look at here, this one carbon atom has 3 visible hydrogens around it. Therefore, that is an alkene. Don't worry, in one of my YouTube short video, I'm going to talk about this. Subscribe and follow us so that you don't get lost anywhere. Whatever update we upload, you will be notified. Remember to turn on the notification bell. Now, coming to this is actually ethyl. That's how we call it. Why do we call this ethyl? How many carbon atoms do you have in this attachment? You have 1 and what? 2. 2 carbon atoms. Now, the prefix of 2 carbon atoms is eth, ETH. If it is an alkane, 2 carbon atoms, we have 6 visible hydrogens around it. Alkane. And I just told you a moment ago that alkene is alkane that has lost 1 hydrogen. So instead of having C2H6, which is an alkane giving you ethane, we now have C2H5 if you count the number of hydrogens, which will now become ethyl. The prefix will be the same, eth, but the suffix will change, ethyl. Alright, that is the attachment we have there. This one is methyl. Having analyzed that, the next thing we now have to do is go for the name of the structure. But we have to start with the names of the attachment first, and indicating the carbon atoms bearing the attachment. Remember, the right direction to count from is this, so I'm using the blue numbering, not the black. Take notes. Having said that, we have methyl, we have ethyl. Dictionary arrangement, or in terms of our 26 alphabets. Look at the initial. This one is methyl, starting with N. This one is ethyl, starting with E. Which one will you meet first? E. Therefore, we'll start by mentioning that ethyl, which of course is on the 4th carbon atom. So this structure would be 4-ethyl, saying on the 4th carbon of the parent you have ethyl attachment, and then on the 3rd carbon atom of the parent you have methyl attachment. 4-ethyl, 3-methyl, and then you now end with the parent name because there's no other attachment. In the parent you have 7 carbon atoms, which correspond to what? Heptane. So this is simply 4-ethyl, 3-methyl, heptane. Good. We are giving it a shot, you know. Moving on to the next structure, number 3. So what have we got in structure number 3? Good. This is the structure. And so as usual, we're going to analyze this, you know, quickly because I've set out the whole pace and understanding of how to handle Iupac nomenclature of alkanes. But let me quickly point out something. You notice that I did not expand the hydrogens anywhere, like you have line here, another one down, another one here, and then distribute hydrogens around, just like I did in structure number 1 and 2. Are you following right? In this case, we've decided to compress down. Instead of writing C and then you expand, you now have CH3, it's still the same thing. You can decide to expand the hydrogens if you want, but that is punishment. Alright, so let's move on to deal with this. Our longest carbon chain, looking at this clearly, is the straight chain. You can find out yourself if you want to count this way in this branch to know whether it is the longest, or you go like this to know whether it is the longest. The choice is yours. But I know from what I'm seeing, the longest chain is the straight chain. So 1, 2, 3, 4, 5, 6. The next question will then be, will I count from left to right or from right to left? Remember the rule where you cite your attachment first. So let us check. If I count from right to left, 1, 2, 3. On the third carbon atom, that is where I cite my attachment first. Counting from left to right, 1, 2. On the second carbon atom, that is where I cite my attachment first. So clearly, the counting should go this way. Are you following right? It has to go this way, not this way. Going this way, even if you want to use the lowest sum concept. If you're counting from left to right, you have 1, 2 on the second carbon atom attachment, 3, 4 on the fourth carbon atom, another attachment. So one could simply do 2 plus 4, and that will give you what? 6. But if you count from the right to the left, you have 1, 2, 3 on the third carbon atom, an attachment, and then 4, 5 on the fifth carbon atom, you have another attachment. There are 2 of them. Okay, so that's going to be 3 plus 5, which would give you 8. Now I'm saying clearly, the one that gives us the lowest sum is from left to what? Right. So I can indicate 1, 2, 3, 4, 5, 6. You see how this numbering I'm putting here? Once we are done with this homologue, I won't bother doing that. It's just because I want you to get the background and unique foundation of this. That's why I'm doing all this numbering. You can actually deal with the structure without full numbering. This is 1, and then we have 2, 3, 4, 5, and what? 6. I've already selected the direction to count from, left to what? Right. Now, in our parent chain, we have these straight carbons. It simply means that this is an attachment, this is an attachment, this is also what? An attachment. And so when you go, if you look at the attachments, they are all the same. CH3, 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 which is methyl, methyl, methyl. Are you following right? Or just for you to still see, otherwise there is no need of writing those names here. So we've got this. All of them are methyl attachments, CH3. Are you ready? Now from here, you're going to add up to the rule. Are you getting me? In terms of when you have maybe the same attachment, 2 or more of them, how do you handle that? So we go. Correct direction of counting we've selected, that is this left to right. Now on the second carbon atom, you have methyl attachment. On that same second carbon atom, you have another methyl attachment. So we have 2, 2. Are you following right? 2, 2. Good. Then on the fourth carbon atom, you have another attachment, which is still methyl. Because the attachments are the same, this is the rule. You are going to indicate the parent carbon bearing the attachment in ascending order, using comma to separate the number or the position of the carbon atoms. You can put it down. Are you following right? You are going to mention the attachment in ascending order using the position of the carbon atoms where they are attached to. For example, here you have on the second carbon atom of the parent, you have a methyl attachment that will indicate second carbon atom of the parent, you have methyl attachment, comma. On that same second carbon atom, you have another methyl attachment, comma. Then moving to the fourth carbon atom of the parent, you have another methyl attachment, 4. So do you see how I positioned the carbon atom bearing this methyl attachment in ascending order? So take note of that. How many of the methyls do we have? 3. Now these 3, you are going to put hyphen between number and alphabet. I am going to use tri. That tri is Latin prefix for 3. Since we have the same attachment and there are 3 of them, we are going to write it as trimethyl. That tells anyone who comes here that there are 3 methyls in this structure as substituent or attachment, as we may choose to refer to it. So that is trimethyl, which means there are 3 methyl substituents. Alright, we are done with the attachments, the substituent, so we can conclude with the parent name. The longest carbon chain, we have 6 of them, and that corresponds to what? Hexane. And so this will end in hexane. The name of this structure is 2, 2, 4, but you don't mention the comma when you were saying, just 2, 2, 4, trimethyl hexane. That's the name of this structure. What additional rule have you learned? Added rule that you learned here is that because we have the same attachment, you are going to indicate their position on the parent carbon at once. Are you following, right? Using comma to separate any number. You know, between number, use comma to separate. Okay? Then, count the number of the same substituent that you have. Here we have 3 methyls that are the same. And 3 has the Latin prefix, tri. So you're going to attach that prefix to that methyl attachment. Trimethyl. Are you following, right? Then you end with the parent name. We're going to move on to structure number 4. Now we take our 4th structure, which of course is going to be the last for this class. And of course the end of the Iupac nomenclature of alkanes. Because you've gotten as much as 90% of the things you need to know about Iupac nomenclature generally. Yeah, believe what I've said. You'll find out as we move on. And now let us look at this structure we have here on the board. In this structure, you will still learn an added rule. Are you following, right? Because this is a bit quite different from what we've done generally and what we'll learn about Iupac nomenclature. But first, as we know, we determine the longest carbon chain. And I would say, if you look at this, the longest carbon chain is 1, 2, 3, 4, 5, 6, 7, 8, 9. Or 1, 2, 3, 4, 5, 6, 7, 8, 9. So the longest carbon chain there is 9, and that corresponds to nonane. I would like to take this one place. Now, which direction would we count from? Is it this direction or this direction? And looking at this, if you go in this direction, 1, 2, 3, on the 3rd carbon atom, you have your first attachment. Let me indicate the attachment. This is methyl, we know that already. And then, okay, 1, 2, 3, 4, 5, 6, 7, 8, and what? 9. You notice that I did not count any one of these as among the parent carbon. Therefore, this part is also an attachment. Now, it is from this part that you will learn an added rule to what you've learned so far about the rules of Iupac nomenclature. And once you grab that part, in fact, I am going to shoot your level of understanding to 98% of what you should know about Iupac nomenclature for aliphatic hydrocarbons. Are you following, right? That's a high percentage of understanding, you know that. Don't worry, we are coming to that. It's very simple. Okay, so having known that the longest carbon chain is 9, however we name this, the parent name will be nonane. On the 3rd carbon atom, I have methyl attachment, CH3. Then on the 4th carbon atom, I have this whole attachment. Now, I want you to take notes as I guide you on how we handle this type of attachment. Because, yeah, generally, around here we have 4 carbons. 4. The prefix of 4 is but, you know. As an attachment, generally is an alkyl, so it should be butyl per se. But that you have 4 carbons here does not mean that this attachment is butyl. It is not butyl. If it is butyl, this CH3 will not be here. The CH3 will end here, and in fact, this CH3 will be CH2. One hydrogen will come here. It's going to be something straight like this. Let me show you. It's going to be CH2, where this carbon is linked to this parent number 4. Then we have this one as CH2. This CH3 will be CH2. Because one hydrogen from it will be added to this one to give us this CH2, which is linked to the parent. Are you following? And then this CH3 will now end it. This is our normal butyl attachment. This is not the way that attachment, that substituent is. Are you following? So follow as I guide you. You know, generally, when we come to the substituent part, we have to know the longest carbon chain there as well too. So I will know the name to give to that attachment. For example, in structure number 2, you remember when I numbered that 2 carbon atom 1, 2, and I told you the prefix is 8, giving us ethyl. So in the same way, if you come to this is the carbon directly linked to the parent carbon number 4. So from this carbon, we are going to number it as number 1. And then from it, we'll find out the longest chain in this attachment. So let me ask you, you have 1. Would you go this way as 2? Is that the longest direction of the chain in this substituent? No, that's good. But if you go this way, you have 3. 1, 2, and what? 3. Good. Which means I'm going to go in that direction. Then I have 2, and here 3. This simply tells us that this carbon, this CH3 you are seeing here is an attachment. Let me star it. It simply tells us that it is what? An attachment on this 3 carbon attachment. Please take note. 1, 2, 3. This is the main substituent. This is the main attachment on this parent carbon number 4. On this 3 carbon attachment, you now have this CH3 attached to number 1 of it. So this is just like, you have the whole parent now. It's just like a parent giving birth to this person, and then this black giving birth to this blue. Now this blue will bear the name of this black because it came from the black. And then the black, which is now attached to the parent, will bear the name of the parent. That is the idea. So we are just interested in this part. And I call that part substituent on substituent. Or I call it attachment on attachment. Because these 3 carbon atoms you see here is an attachment on this carbon number 4 of the parent. Then on the first carbon of this attachment, you have this CH3 substituent. So this CH3, which is methyl, will bear the name or end in the name of this 3 carbon atom. 3 carbon atoms as an attachment is propyl. Remember, the prefix for 3 carbon atoms is prop. Then as an attachment in alkyl level is propyl. Take note of that. So coming here, we'll say on the first carbon atom of this propyl, we have methyl attachment. Have I said something reasonable? Why not replay what I've said while analyzing this part? Because the name of this whole attachment now on Iupac level is called 1-methyl propyl. Let me indicate it. This whole part is 1-methyl propyl. Propyl is the name of this attachment. And then on carbon number 1 of it, you have this methyl, giving us 1-methyl propyl. And that is what you should know about that. Now, when we want to write this out, when we are giving the Iupac nomenclature, this substituent on substituent will be enclosed in parentheses, brackets. We would write on the 4th carbon atom of the parent, then after hyphen you have in bracket, you put the name of this substituent on substituent. So that is the added rule that you should know. I don't want to speak one kind of long grammar so that you don't stress yourself. Follow along just what I explained. I've told you why this is substituent on substituent. From this carbon number 1 directly linked to this parent, this begins our attachment. There are 2 branches. Sometimes you might even have 3 branches from it. Take the longest branch. That will now give you the main attachment. The other ones will simply be substituent on that substituent. So let us go, please. We have methyl attachment on carbon number 3. We have 1-methyl propyl attachment on carbon number 4 of the parent. Question. If I give you methyl as a word and I give you methyl propyl as a word to find in dictionary, which one do you think you will see first? Okay, you will see methyl first. Methyl propyl will come after because you must be done with methyl before adding P to it. It simply means that this will come first. The name of this structure becomes 3-methyl 4 hyphen open bracket 1-methyl propyl. The longest carbon chain here is 9, so it will end in nonane. 3-methyl on the parent chain, okay? Then on the parent carbon number 4, Are you seeing that, right? Then now open your parentheses. We have 1-methylpropyl. There is no other attachment, so we conclude with the longest parent, which is nonane, because we have 9 carbon there. Nonane. So this is the name of this structure. Of this whole explanation, what I'm interested in is how I handle this part. So please, you can take the video backward and then rewatch what I analyzed here. Once you get that, remember I've told you, you have learned 98% of Iupac nomenclature. The other homologs that you are yet to learn, which we'll treat from our next class, we're entering alkanes. They follow everything we've explained here in terms of the rules so far. The only thing we just have to do there is get to know the functional group of that homolog. The rest is just stories. Because before our next class, if you've watched this video lesson and grabbed the whole idea, then I will be very fast in the next class and you will enjoy it. If you have any question, please, you have a comment section, post the questions there and I would be right there to respond to your question. Thank you for watching. Remember to subscribe to the GMAS41's YouTube video. There are still lots to learn. Turn on the notification bell so that once I upload any new content, you will be personally notified. Do not forget to like and comment on our video lessons and of course, share them. Invite your friends to subscribe to the GMAS41's channel as well too. To get a full range of learning, we operate on Telegram, our full classes. You can contact us in order to get a subscription to that at an affordable fee. You have a wonderful day. See you in our next class. We'll treat Iupac nomenclature of alkanes.